Hey again, it's Mr. Lum, and in this chemistry lesson we're going to be talking about significant figures. So, significant figures are when measurements are taken, they cannot be exact. For example, I have a few examples here. My height is 185 centimeters. Now, is it exactly 185 centimeters, or is it possible that my height could be, 184.8 centimeters or 185.2 centimeters? And those numbers are very, very possible. Okay, so height is an example of a measurement, and therefore cannot be exact. Exact numbers are obtained through counting objects. So my next example right here is I have 12 eggs in my fridge. Is it possible that I have 11.9 eggs in my fridge, or 12.7 eggs, or 12.4 eggs in my fridge? No, I have 12 eggs in my fridge. Okay, or there are 2 people sitting at the dining room table. Okay, those are examples of exact numbers. So this one is I have 2 dogs. I don't have 2.1 dogs, or 2.2, or 1.8 dogs. 2 dogs is an exact number. So with exact numbers, there is no uncertainty. Okay, they are not measurements. They are obtained through counting. So things that do have significant figures are things like height, weight, mass, time, temperature. They all have a certain amount of uncertainty. So we're going to go through these. As we said, this one has uncertainty. This one is exact. This one is also exact. Okay. My dog's weights are 22.5 kilograms and 18.1 kilograms. These have uncertainty. Okay, it might be 22.6 kilograms. It kind of depends a little bit on my measuring device. How accurate is my scale? How precise is my scale? Okay, so these are some examples of things with significant figures. These are measurements. So I'm going to write M beside things that are measurements. This dinosaur bone is 70 million years old. Okay, so if I make a statement like this, does that mean next year it's 70,000,001 years old? And the answer is no. 70 million, when we talk about numbers like this that are very, very big, and this is a measurement of time, there is a certain degree of uncertainty here, and therefore this has significance, or significant figures. So again, this is a measurement. Now, there are 7 billion people on the planet. Now, this one can be a little bit confusing, because you would think that, well, this was obtained through counting how many people. But when you have a number like 7 billion people on the planet, this is an approximation. No one directly counted. There's not exactly 7 billion people. So does this number is an approximation based on modeling, and therefore it is a measurement. Okay, so does this have significance, or is this a significant figure? Yes. It is not an exact number. Okay, so a little bit description of what is an exact number and what is a measurement. So now that we know what measurements are, here is a ruler. So here's something that is being measured. So how do you tell how many significant figures are present, and what is it? So we have an object right here, like this could be an eraser or something like that, but we have a black eraser or something like this, and then we're measuring it. And so significant figures, they are certain digits plus one uncertain digit. So someone can say, you know, oh, this is 1.05000000 centimeters in length. We can't really make that statement based on our measuring device here. So how are we going to obtain what is the length of this thing? So how we do that is, well, through significant figures, we're going to go take all the certain digits and we're going to plus one uncertain digit. Now what does that mean? So we're going to write down, what are we certain about here? Okay, I am going to take this and we're going to measure it. It's right about there, so it looks like it's coming down just past the 1. It's definitely less than this 1.1 centimeters here. So we see 1, 2, 5, 6, 7, 8, 9, and so each one of this is a 1/10 of a centimeter, or 1 millimeter. Okay, so I'm pretty certain that this is, well, I am certain that this is greater than 1.0 centimeters. Okay, so I'm certain that it is greater than 1.0 centimeters. I'm also certain it is less than 1.1 centimeters. Okay. Now, where this lands in between here, it can be up for a little bit of debate. So one person might say, well, you know, I think that is, you know, 2/10 of the way down here, and someone might else say, oh, that looks about 3/10 here. So it's a little bit uncertain, but you know, I'm going to say that looks about 2/10. It looks about 2/10 of that distance right here. Okay, and someone can very, very well argue, whoa, that's 3/10 right there, and they would have a valid argument. But what we're going to do is, what we can say is this last digit, this last number right here, we're definitely uncertain about it. But we're certain it's greater than 1.0 and less than 1.1. So we take all of our certain numbers. It's greater than 1.0, less than 1.1. So it's going to be 1.0. Now, and we take one uncertain digit. Now here's the uncertain digit that I took right here. So I'm going to say it's 1.02 centimeters long. Okay, so we have our certain digit, and our one uncertain digit. Okay, so how many significant figures do we have here? Well, there are 3 significant figures. 2 certain digits, 1 uncertain digits. So there's 3 significant figures here. And the length of this ruler is 1.02. If I said this length of this ruler is 1.02539, well, I can't really say that, okay? Because I then am adding too many uncertain digits. I just can say there's 1 uncertain digit here. So, continuing on with certain and uncertain digits and significant numbers, when there is a 0, here's a little rule about significant figures, or as we say, sig figs. When there is a 0 at the end of a number, it is usually insignificant. Now, we use this in our common language. For example, getting back to the dinosaur bone example, if we say something is 70 million years old, well, what does 70 million mean? So 70 million years old. Well, we are certain it is, well, we are certain that it's a very big number. We're uncertain pretty much about all of these digits right here. So let me give you a little bit of a better example here. Let's take the 65 million years old. So right here we can say, well, we are certain that it's not it's less than 70 million years old. Okay, we're certain about that. Now, this last number right here, it could be 64 million, it could be maybe 66 million years old. So this is a certain number right here. We're sure that it's not 50 million. We're sure that it's greater than that. We're pretty sure that it's less than 70 million. And this number right here can be up for a little bit of debate. These numbers here, we are pretty uncertain about these ones. Okay, so we just put zeros right here. So how many significant figures is this? This is two significant figures. Our certain number plus our uncertain number. And we kind of know it's not that if a dinosaur bone is 65 million, it's not next year or 2 years from now. Someone will call it, oh, 65 million and 2 years old. So we kind of use that in our common language. Those zeros are uncertain. So how many significant figures are present? Let's do a few examples. How many significant figures are present in the number 120? So it has a 0 at the end here. So our certain digit, our uncertain digit, and this one is insignificant. So we have how many sig figs here? Are 2 sig figs. Okay, same thing for this one. One certain, one uncertain, and so this is 2 sig figs as well. Okay, this one we don't have any certain digits. We only have one uncertain digit, so this is 1 sig fig. Now, when you get an example question like this, or an example like this of 6,001 years old, or whatever the unit may be, it's going to be, these are not trailing zeros. They're zeros in the middle. So this is our certain digit, this is our uncertain digit, and we can only have one uncertain digit, so all of these ones must be certain as well. So how many significant figures are present here? 4. 1, 2, 3, 4. So when there is a 0 at the end of a number, it is usually insignificant. These zeros are in the middle, not at the end. So here's another one, certain. Now we have a 0 at the end. However, it's after the decimal place. Okay, so that's going to make this one our a significant figure as well. So this is 2. And think about this in common language. If I said, well, how old is your dog? And you said, well, he is 1 year old. Well, that's a big difference from saying 1 year or 1.0 years. That means, he's not 1.5, he's 1.0. Or if I said something like, how old are you? And you said, well, I'm 18 years old. Okay, that would be 2 significant figures. So if you said you're 18, that's 1 certain digit and 1 uncertain digit. But if you change that and you said 18.00000 years old, well, that would be more pertinent information, because then I can decipher if you're 18.00000 years old, then I would conclude that, oh, today must be your birthday. Okay, because all of these numbers, if you're 18 and 1 month old, then there'd be a few numbers right here. Okay, so these numbers are significant after the decimal place. So there's 2 sig figs here. So we have 2 zeros here that are after the decimal place, and so that is 4 sig figs. Now here we have some scientific notation, and it has what we can do if we're thinking about sig figs. We can just ignore the scientific notation and just look at it as 1.00, and we just think certain, certain, uncertain. So that'd be 3 sig figs. Okay. If you were to write this out in a little bit bigger way, it would look something like that 1, 2, 3, 4, something like that. 10,000. It looks like it's only one sig fig. So if you were to want to communicate to another scientist that no, I am certain about the first three numbers, I'd write it in this manner like this. Okay? So that brings us to our next thing, leading zeros. So trailing zeros are insignificant. Leading zeros are also going to be insignificant. So here are some leading zeros. Okay. These are going to be insignificant. But these trailing zeros, since they're after the decimal place, these trailing zeros are after the decimal place, they are significant. So we're given, again, 3 sig figs. And this one, I forgot to raise this or superscript this one, but it should be 3.0 times 10 to the minus 3. Again, you can ignore the scientific notation and go 2 sig figs right here. So this one's going to be 2 sig figs. If I were to fully write this out, it would again just be 0.00 like this. And this would also just be 2 sig figs. So you could write this one in both ways. But it's still going to be just 2 sig figs. Now, how many sig figs is this one? We have some trailing zeros, but they're after the decimal place, so they're good. We have some kind of zeros here. Now, are they leading zeros? Well, no, because we have it leads with this 2. So they're kind of zeros that are sandwiched. So that means they are significant. So we have 1, 2, 3, 4, 5, 6 sig figs. Last one, we have a leading 0, so it's not significant. A trailing 0, but it's after the decimal place, so it's significant. And some sandwich zeros, so those are also significant. So 1, 2, 3, 4, 5 sig figs. Okay?